This is example 3. It says find all the zeros. So they don't just mean the real zeros now, which we can probably see on the graph. They mean all the zeros. So in this case, how many zeros is that? Well, because the degree is 5, then we would expect 5 zeros. So the strategy here, we could make a list of the possible rational zeros, try synthetic division until we find one that has a remainder of 0, and then go from there. But realistically these days, because of a graphing calculator, we're not going to do that. We're going to graph it and see if we can find the real zeros by looking at the graph. So let me look at this in the calculator and then look for the zeros. And you can see here, if you can follow the cursor, there looks like there's a 0 at -2. There looks like there's a 0 at 1. And I can confirm that by looking in the table of values. Right? At x equals -2, y equals 0. At x equals 1, y equals 0. But more than that, these zeros don't look the same. The x equals -2, the graph goes right through -2, which means that the factor is changing sign when it gets there. When you see this kind of thing, at x equals 1, the graph touches the 0 and then goes back in the same direction. That means that the 0 is coming from a factor which is squared. So that's probably x minus 1 squared. So for our purposes here, that means that we are going to say we have found zeros of -2, 1, and 1. Okay, now we need to use those zeros with synthetic division to reduce this polynomial from a 5th degree to a 4th degree to a 3rd degree to a quadratic. And then we can finish with the quadratic formula. So first, put the 0 in the bracket, put your coefficients, and notice we're missing x to the 4th, so I fill in with a 0 for x to the 4th. 1, 2, -12, and 8. Right. Draw a line, bring down the 1, -2, add. +4, add. -10, add. +16, add. -8, 0. Which is what we expect. If you didn't get a 0 as a factor there, then you would have to see what you did wrong, because we know that -2 is a 0. Okay, so now let's do 1. On that set of numbers, bring down the 1. 1 times 1. 1 times 1 is 1. Add. 1 times -1. Add. 1 times 4. Add. 1 times -4. Add. Again, we got a remainder of 0, which we expected, and now we need to use 1 again. Bring down the 1. 1 times 1, 0. 1 times 0, 0. 1 times 4, 4. Remainder is 0. So that confirms that 1 is a 0 twice, because we got remainders of 0 both times. Okay, these are the coefficients of a quadratic. This would be x squared plus 0x plus 4. So for our last two zeros, we have to solve this equation. So subtract 4 to the other side. Take the square root of both sides. That is plus or minus the square root of -4. And now that's the square root of a negative number, which means we're going to have an I. And this is 2i.